Welcome back, everybody. Today we're going to start talking about area and arc length in polar coordinate. So let's first focus on area. If you remember uh, in the beginning, in your trigonometry class or in Calc 1, we've mentioned that area of a sector of a circle. You can calculate the area of a sector of a circle throughout based on the radius and the angle of that sector. So if you have the angle theta and radius r for a sector of the circle, then basically this area would be 1/2 r squared theta. And if it's a full circle, then theta would be 2 pi. So what you get is 2 pi times 1/2, which is pi r squared. That's going to be the area of the full area of the circle. We're going to use that to discuss what happens if you have an equation r equal to f theta. So if you're dealing with polar coordinate, what happens regarding area under the curve. So let's assume we have this curve, this green curve, R, and this curve is represented by the equation R equals to f of theta. Okay, if we're looking for area under this curve, meaning this section between the angles theta from A to theta from to B, I shouldn't say under the curve, I should say the area bounded between these two angles, angle from A to B. So here is correspond to the angle A and up to the angle B. So let's say we want to find out the area in this section. What you can do is you should try to again approximate similarly to what you do in Calc 1. So we break it up into smaller sections, and in each section you calculate the area. So I'll divide this into multiple pieces, and in each piece I will try to approximate the area. So if you look at the area for one of these sections, so let's call this section delta A. So you're looking for this area. So delta A represents approximately the area in this section, and it is kind of close. If you look at this curve and say this curve is almost close to the section of a circle. It's not exactly the same, but if you make this length to be smaller and smaller, then it will be closer and closer to a, section of a sector of a circle, a section of a circle. So what we can say is we can say delta A is almost the same as 1/2 radius squared multiplied by the angle. So the angle is a portion of the angle, which is delta theta, and the radius you can consider this point somewhere between, which is depending on the f of theta, wherever theta is, that would be the radius. So we say approximately it would be 1/2 times f theta squared times delta theta. This is for this specific section. Normally you should say theta I corresponds to that ith section. And if we sum up all those sections, then together what you have is a good approximation of the area. And as you let the number of sections to be more and more, then your approximation would be better and better. So basically what you can say area, if you take a limit and sum up all of those, you can approximate it by writing an integral. Area would be sum of all those sectors, or you can say area would be 1/2 f theta squared d theta integration from A to B, where A is the smaller angle here to B the terminal state. So this is basically if you want to calculate the area. You use this formula. F of theta is the radius function based on theta, and A to B is the corresponding angle from A to B. Here's an example. So let's say we want to find out the area in the enclosed by the loop from theta from negative pi fourths to pi fourths for this curve, for this equation r equals cosine 2 theta. And if you remember in the earlier section, we kind of graphed r equals cosine 2 theta, and it looks like this flower thing. So if you want to find out what is the area? Basically, we're looking for this blue section area from negative pi fourth to pi fourth. And then if you want to find the whole area enclosed, you just need to multiply by 4. So in this case, we're only looking for one of those flowers. So what we do is we say the area, change it to green, the area would be the integral from negative pi fourth to pi fourth of 1/2 radius, which is cosine 2 theta, squared d theta. And now at this point it's just simple calculation of the integral, and that is from negative pi over 4 to pi over 4, 1/2. Cosine squared 2 theta is the same as, if you remember, using trigonometric identities, it's the same as 1/2 1 plus double angle cosine of 2 times 2 theta would be 4 theta. This is by doing by using the identities that we have. There's a trick to get rid of the power, reduce it to a double angle. So from negative pi over 4 to pi over 4, we have 1/4 plus 1/2 cosine 4 theta d theta. And if we integrate, integral of 1/4 is 1/4 theta. Integral of 1/2 cosine 4 theta would be 1/2 times, you should call 4 theta u and then integrate, but we can simply say this would be the integral, sine 4 theta. It's quite easy to calculate. From negative pi fourth to pi fourth. So if we replace pi fourth in there, what do we get? So if we replace pi over 4, we get 1/4 pi over 4 plus 1/8 sine of 4 times pi over 4 becomes sine pi. And if we replace negative pi over 4, we get 1/4 times negative pi over 4 plus 1 over 8 sine of, replace negative pi over 4, you'll get negative pi. And sine negative pi and sine pi, they're both 0, so this becomes 0, 0 here. And we have pi over 16 minus pi over 16, that simplifies to pi over 8. So the area of this flower is simply pi over 8. And if you want to find the whole area, you just multiply by 4 and you will get pi half as the total area. Okay, so this is the case. If you're given where to bound it, it's quite easy. It's just calculation. But sometimes you don't have that specific format. Here, find the area of the region that lies inside this circle and outside that center. So what you do is, if we don't know how to graph it, just first you need to figure out where is the intersection. If you remember, you had two functions and you were looking for the intersection. Let's say you had a function f and a function g, and you're looking for the intersection. What you do is you set up f equal to g and you figure out where are these two intersections, and then you say the top function minus the function below, and the area would be basically from a to b. You find out where is a and b throughout solving this equation. Then f minus g dx. This was when we're dealing with x. Similar idea just holds here. So what we do is we set up the two equations, set them equal to each other. So I'll say 3 sine theta must equal 1 plus sine theta. When I solve this equation for theta, I want to find out what is the bound that theta goes through. So you get 2 sine theta equals 1. And that means sine theta equals 1/2. And for what angle theta is 1/2, theta must be either pi over 6 or theta must be 5 pi over 6. This is where we get sine to be 1/2. If you don't remember it, just go use the table for the sine. And what you notice is in the picture, and here is pi over 6 and 5 pi over 6. That means where the two graphs intersect, it's going to be at these two angles. So now what you can say is difference from the top function minus the bottom function, but you don't really need to graph it. In this case, they'll tell you what is the outside, what is the inside. If you don't have that, you can still do the top function minus the bottom function. If the result is negative, you just need to take an absolute value of the result, since we're discussing area. So in this case, they say lies inside the circle and outside this. So this kind of tells you that this is the outside function, or maybe I should say top function, and here is the function on the bottom. Function. Okay, and graphically you can kind of see it, the top and here is the bottom. And since you have the graph, what I'm going to do is instead of going from pi over 6 to 5 pi over 6, I'm going to cut it off at pi half. This is the angle pi half. Then by symmetry, you can multiply the result by 2. So what we can do is, instead of integrating all the way, I can say let's calculate the integral. Instead of saying from pi over 6 to 5 pi over 6 for the area, it should be from pi over 6 to 5 pi over 6 of 1/2, what is it, r, which is 3 sine theta squared, minus the area of the bottom one, which is 1 plus sine theta squared, then d theta. This is the same as calculating from pi over 6 to pi half. Up to here, figure out what is this area, then multiply the result by 2, so 2 times that. This 2 times 1/2 and 1/2 will kind of cancels out, so you basically get 3 sine theta squared minus 1 plus sine theta squared d theta. And it makes it easier. We're dealing with less coefficient, that's why I multiplied it. Okay, now let's calculate integral from pi over 6 to pi half. And sine, you'll get sine, I forgot a 3 here. There we go. You get 9 sine squared theta minus sine squared theta plus, minus 2 sine theta and minus 1 d theta. You can kind of simplify it a bit more. You have pi over 6 to pi half sine squared theta, 8 of them. 1 will cancel out, minus 2 sine theta minus 1 d theta. Integrating these two is not difficult. To integrate this one, we have to use that half angle identity, double angle identity, and say this could be written as, similar to the last example, pi over 6 to pi half, 8 times 1 plus, there's a 1/2, sorry, 1 plus, sine squared is the same as 1 plus cos, 1 minus cosine 2 theta. Sine squared is the same as 1 minus cosine 2 theta, or 1/2 times. And that simplifies to 4 here. And we have minus 2 sine theta minus. A bit more simplification before I integrate is a good idea. So you have 4 minus 1, so you get 3 minus 4 cosine 2 theta and minus 2 sine theta, d theta. I forgot the d theta. Okay, now we can integrate the integral of 3 theta, the integral of negative 4 cosine 2 theta would be minus 4 divided by 2 sine 2 theta. So this gives you simply 2. And integral of 2 sine theta becomes negative cosine theta, so plus 2 cosine theta. Evaluated from pi over 6 to pi half. So finally, replacing pi half and pi over 6, you get 3 pi half minus pi over 6. We're going to replace it for both of them and subtract at the same time. Minus 2 sine 2 times pi over 2 would be sine pi minus sine pi over 3 and plus 2 cosine of pi over 2 minus cosine of pi over 6. The terms that are 0, this is 0, that is 0. And what is sine negative pi over 3? This is sine 60 degree was root 3 over 2. If I'm correct. So this is root 3 over 2. And cosine of pi over 6, that's the same. So this is root 3 over 2 as well. So what do we have? We have 3 pi half minus pi over 6, by the way. This is pi over 3 pi over 2, 3 pi over 6 minus pi over 6. That is 2 pi over 6, so pi over 3. 3 times that would be pi minus 2 times negative root 3 over 2, so plus 2 plus root 3, and plus 2 times that and minus root 3. So at the end you simplify, you get simply pi. So this is the area bounded in this section, the whole thing. Okay, make sure that I haven't made any mistakes, double check my work. Unless I've made calculation errors, this is the idea basically, to calculate the area. Arc length is quite easy because we've done parametric equation, so we kind of write, we know that in polar coordinate x is the same as r cosine theta, y is the same as r sine theta. So if you have a curve r equals f of theta, you can simply find out what is dx over d theta and dy over d theta, and we did that earlier in the last section. Said it is dr over d theta cosine theta minus r sine theta, and on the other side dy over d theta is dr, you're taking derivative, it's like using product rule, derivative of the first multiplied by the second plus derivative of the second multiplied by the first. So we get dy over d theta as well. Now if you remember, to calculate arc length, what you need to do is find out what is dx over dt squared and dy over dt squared, and you add those parametric terms, those derivatives together, squared over, you take a square root, and you integrate. So in this case, dx over d theta is simply this term, and dy over d theta is this term. And if we square them and add them up together, you can kind of simplify it, because sine squared plus cosine squared would be 1, so you can use those and simplify. And the simplified version turns out to be r squared plus dr over d theta squared. So for the polar coordinate, this becomes the integration if you want to find out the arc length. So for example, if you want to find out the arc length of the curve, r equals 3 sine theta from 0 to 2 pi, what you need to do is, you can say the length becomes from 0 to 2 pi. These boundaries are for theta. This corresponds to theta. So from 0 to 2 pi, and calculate the square root of r squared plus dr over d theta squared. So what I need is I already have r. I just need to figure out what is dr over d theta. And dr over d theta in this case is simply 3 cosine theta. So what do you get is integral from 0 to 2 pi square root of r squared, which is 3 sine theta squared, plus dr over d theta, 3 cosine theta squared d theta. And if you add them up, you'll get 9 sine squared plus 9 cosine squared. Factor out the 9, you get sine squared plus cosine squared involved, that is 1. So this square root simplifies to just the 3 d theta. And what is that? The integral of that is 3 theta evaluated from 0 to 2 pi, which gives us 6 pi minus 0, which is simply 6 pi. And this is quite easy to calculate. This r equal 3 sine theta is basically a circle of radius 3. And what is the length of a curve? In this case would be basically the parameter of the circle. The parameter of a circle would be 2 pi r, which in this case, which is 2 times 3 times pi, so which is 6 pi. It becomes a double check. The only issue is to find the arc length is always not that easy to calculate the integrals. In some cases, maybe you need to use calculators to calculate. So if that case happens, try first if you can calculate the integrals. If not, then maybe use a calculator. Okay, that's about it for this section, so I'm going to stop at this point.